Okay, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1108. Hopefully you guys are okay. Is anyone here? I don't see anybody. Oh, there we go. Kathleen's here at least. Okay, so awesome. Let's actually jump into it. So it's going to be a short class today because we're going to wrap up chapter 3, but I don't really feel like starting chapter 5 because it's like a whole other thing. So I don't want to think it's like conceptually or psychologically or whatever you want to say. It's kind of weird to go from one thing to the other. So we're just going to wrap up chapter 3 with the 2 examples that I left you guys to do. And I am then going to do a much needed, I assume, summary of chapter 3 in terms of the formulas we've covered and when you want to use them, because there has been and will be some confusion about that. So let's actually jump into that. Okay, so hopefully you're seeing my screen. That looks good. I can see the chat. All right, so this is where we were. This was what we did on the 17th. We spoke about sinking funds and the sinking fund formula. That's this guy. We used that in an example. Then we started talking about present value of annuities and amortization. And that was like we derived this formula, right? So that was the present value of annuities. And we use that to do an example, but I left you guys with a couple examples to try. So what we're going to do now is go through those examples, see what you guys got. And then right after that, we're going to kind of just do a summary. And that hopefully will set us up for chapter 5 next week, which is it's going to be a cool section. Hopefully you realize it's cool. Students don't always realize how cool that section is. But hopefully, by the time you get there, you'll realize how cool that section is. Because it seems very esoteric, like no one does that stuff, but actually almost everyone does that stuff. It's one of those things. Yeah. So these were the examples from last time, and that's what we're going to do. So let's go. All right, so here's the first example. So this is a loan example. So a loan firm will lend you $100,000 at 3.99% APR compounded monthly. What would your payments be if you have to make fixed monthly payments over a loan term of 5 years? So situations, whatever. Maybe you want to start a new business. You never heard of GoFundMe. You're like, I need $100,000 startup capital. Your uncle won't help you out. Your mom won't help you out. Your parents won't help you out. Your friends won't help you out. So you're like, okay, fine. I have to go to a financial institution. You say, can you lend me $100,000? And they're like, sure, I'll lend you $100,000 at 3.99% APR compounded monthly. What would your monthly payment be to pay that off in 5 years? How much will it cost you per month to borrow $100,000 is the question. Okay, so we are going to get into that. We're going to figure that out with the amortization formula. So we saw that, and I'll just remind you, we saw that, and this is the version of the formula that we derived at first. It had present value on this side equals payment 1 minus 1 plus r over n to the minus nt over r over n. Okay. But of course, but if we care about payment, we can actually solve for payment. Right? So we can solve for payment. That's going to be equal to PV times R over N over 1 minus 1 plus R over N. So here, we actually know the present value. This is what I'm getting in the present. Someone's handing me this much money right now. And so I want to know what my payments would be. It says here, what would your payments be? Which means the PMT is what you don't know. So I'm going to use this formula to try to figure out the PMT. That's that. And here, of course, our present value is 100,000. That's what I'm getting right now today. Interest rate they're charging me is 3.99%. It's compounded per month, so that's 12 times per year, and I'm borrowing this money for a loan term of 5 years. So this means my payments should be, or what this person is going to quote me if they are being honest, and I'm going to check them because $100,000 is a lot of money, is going to be, I'm just going to plug into this formula, 100,000 0.0399 to 12, right? So that's 3.99% over 12, 12 times compound per year. Right, so again, that's 3.99% compounded 12 times per year for 5 years. So that's going to be the calculation. That's going to be my monthly payment. And what do we get for that?
I got 1,841 and 20 cents.
1,841 and 20 cents. I agree. That was Kathleen, right? I agree, Kathleen. Okay, so you know how to use your calculator. Congratulations. Better you know now than realize on the test that you don't know. So yeah, that's what you should have gotten. And you all should try that to make sure that you got that. But yeah, that's how much it's going to cost you to borrow $100,000 at that interest rate. Now, is anyone going to lend you $100,000 at 3.99% APR? Chances are no. So, like, you want a loan like that. If you're kind of like a nobody with average to poor credit, they're going to hit you with 15, 16, 20% for a loan like that. If you have a high net worth or good credit, maybe 9% you can get away with, especially if you kind of try to open up a line of credit for 100,000. You know, with a decent credit, you can get that at like 9% for as you spend it. They charge you 9% compounded. But yeah, that's the thing. And someone asked me in the last class that, well, you know, we could have just actually got it for cheaper if we just spread things out. But chances are, with loans like this, they don't spread out that far. No one's gonna like lend you 100,000 for a business loan and be like, pay me back whenever. You can pay me back in 30 years, 50 years. Like, no, it doesn't happen. With mortgages, things like that can happen, right? Like your mortgage can be a 15, 30-year loan. And so they can get to stretch it out, and therefore they can charge you a lower interest rate so that they'll tell you, oh, on your mortgage, we're going to charge you 3%, blah, blah, blah. And you're like, that sounds great. But of course, over 30 years, you know, we now know better that they're actually making a lot of money off of you by charging you 3% for a mortgage, right? So yeah. So if you're spreading out for a long time, they can charge you a lower interest rate because overall compound interest is going to really get them a lot of money off of you. But yeah, so don't just think you're going to walk into a bank and get 100,000 at 3.99% APR. I don't want to give you that impression. It was just a random number. Chances are you would have to pay a lot more, because chances are they're not going to give you a loan for more than 5, maybe 10 years. Like that. Okay, so let's look at another example. So you want to buy a car, let's say, right? So you're financially responsible. You budgeted. You figure out how much money you have, how much you need to pay for rent, food, entertainment, all that good stuff, and you realize, you know what? I can afford to use $450 a month on a car payment, right? Of course, you already accounted for the insurance on the car and gas and all that stuff, and maintenance and stuff like that. But you're like, okay, to pay down a car loan, I can put $450 in. So you know your payment, right? Right. So this is your payment, right? So that's known. Okay. So now you're like, okay, I can do this. I want a car. So now, unfortunately, you know, you don't have great credit or whatever, so you can't get a really good deal because remember, as I mentioned, car loans should be simple interest. But here, this car loan is compound interest. Why? Because they're like, no credit check. You just need to have a job. You have a job and you drive, right? So I'm not going to check your credit. I'm not even going to make sure you can pay for this car. Show me a pay stub. You drive the car, right? So you're like, all right, so I'm just going to go to these people right here and give them my money because then they don't have to check my background or whatever, right? So this is a deal you want to take advantage of. So you walk into a car dealership, you say, all right, you're not going to tell them what you want for a monthly payment, but you know in the back of your mind because you planned for it. So now you go in and you're like, what car should I negotiate for, right? Should I ask them for a $50,000 car or a $30,000 car, $10,000 car? Like what car can I afford for $450 a month if I'm being charged this interest, right? So that's what we want to figure out. So essentially what we want to do is find the max purchase price, which in this case is going to be the PV, the present value, right? So that's what they're going to loan me right now to get the car, right? And then I'm going to have to use PMT, which in the back of my mind, I know what I want that to be to pay down that debt over a 5-year loan term. So how much car can we afford for this is the idea, right? So this is called the max purchase price problem. It's like when you know how much payments what payment you can afford regularly, and you know what interest you're going to be charged, how much debt can you responsibly take on, right? So now here, I know what the payment is. That's $450. I know my interest rate is, they told me 2.99%. I know it's compounded monthly, which is crazy for a car loan, but I don't want them running a credit check or anything like that because they wouldn't find good news and they'll probably charge me a higher interest rate. T equals 5 is the loan term. So then what you can do is you can use the present value of annuities formula. So we know that is PMT, 1 minus 1 plus R over N to the minus NT over R over N. So we are going to plug that in. At $450 a month, if they're charging me 2.99% compounded 12 times per year for 5 years, someone's coming in. Let me let them in. For 5 years, right? So again, that's 2.99% compounded 12 times per year. How much car can I afford? Help me out. So what's the maximum car loan I should get here? Is anybody there?
Hey, sorry, I had to go to my calculator.
Is it 25,049.76?
You 25,000 49.76, you said?
Yeah.
That's what I got. So we'll take that as the right answer. So yeah, that's what I got. So that's how much car you can afford. You can afford a $25,000 car under these conditions. So don't walk into the car dealership and start asking for the $50,000 car. It's not going to work out for you, right? But if you see a car you really like and it's like 27,000, then you can go and be like, so my dude, hook me up, man. I'm here to buy a car. I'm a serious buyer. That car over there, I really like it. 27 is too steep though. How about you give me for 20? I mean, come on, like you got a quota to fulfill, right? And they're like, no, bro, I can't give you for 20. Come on, it's priced at 27. I can go down 26 for you. Oh, man, that's going to be no good, man. Come on, I got bills. I'm trying to go back to school, trying to get my life right. All right, 22. How about 22? 22 and a half, maybe. I can't go, like, you're killing me doing it. Nah, man, I can't do 22. I know. Let me go speak to the manager. They go away, they come back, and you're like, good news. My manager says we can give you for 25.5. And you're like, man, my wife's going to kill me now. Hold on, let me go. Let me call my wife. And all right. My wife gave me permission. I can go up to 23.5. 23.5. Just do that for 23.5. I sign right now. I'm out of your hair. You sell a car. You get another thing on your quote, and you're like, all right, you know what, kid? I like you. I'm gonna give you for 24.5. Like, deal, right? So you get it, right? So you know what price you can afford. So of course you lowball them, right? Because they're not gonna go for that price. You ask them for that. This is what I want. They're not gonna get it's back and forth. Okay, yeah. But of course, just so you know, when you're buying a car, especially depending on the state, just make sure that you know of all the hidden fees. They're very savvy with that, car dealerships. They'll try to send you like an extended warranty, and sometimes they just put on document fees and processing fees and this fees. And especially like if you're in Jersey, whatever price you agreed on the car, by the time you sign the paperwork, it's going to be $2,000 more than the price you agreed. So what you kind of do is you kind of say, you know what? I want this for the out the door price. So when you say that, they know, oh, this dude knows what he's talking about. He wants the price for when he signed it and he walks out the door. That means after we put in our fees, this is what he wants to pay. So that's how you kind of can get around that. Like, what are the fees you're going to pay me, right? Fees included, everything, me sign walking out the door, this is what I want to pay, right? So it's going to be different from the actual price that you guys agreed on. So that's just a pro tip right there. But yeah, as a general ballpark figure, that's the car you can afford, a $25,000 car under these conditions. So this is the problem called the max purchase price problem. If you know your payments and you know what interest you're being charged, what is the maximum price that you should be purchasing something for? It's called the max purchase price problem. And you use the amortization formula for it because you are paying down a debt. Okay, so that is, that wraps up the examples for chapter 3. But of course, at this point, what I want to do is kind of like a summary, because at this point, we've seen a lot of formulas, and it might get confusing to know when to use which, because you're going to be reading word problems and you're going to, wait, which formula did she, I don't know, right? So even if you're a ninja when it comes to using your calculator, you actually do it when I ask you to, and you know you can use the calculator correctly. You might not know what should I be plugging into my calculator. So that is an issue. So let's actually do that summary of formulas in chapter 3. Someone got kicked out. Let me let them back in. Formulas for chapter 3. So we learned a bunch. So let's make sure that we understand when we use which. Two main concerns for us, two main scenarios for us. Life is more complicated, but for us, there are two general scenarios that we need to be prepared for. One is the one-time lump sum payment. And put my Oxford comma in here, the multiple regular payments. So if you've been paying attention, you'll notice that in the earlier parts, sections of chapter 3, section 3.1, 3.2, we kind of had the perspective where you kind of just set it and forget it. I put in a lump sum of money, I forget it for 30 years, I come back and see how much is the balance in the account. Not super realistic, but we needed to know that in order to compute the more realistic scenarios. So this was the one-time payment, right? So this is going to be like the simple interest formula, the compound interest formula, the compound continuously interest formulas that I gave you before in the earlier time. Now there's also the scenario of repeated payments, right? So it's not like you just make a payment one time and forget about it. You're consistently making a fixed amount of payments every month for some reason, right? Either you want to save up for a college fund or you want to pay off a car loan, but every month you're putting in a certain amount of money. So this is multiple regular payments. So the first thing you want to do when you're reading a word problem is to figure out which of those situations you're in, right? Now, once you're in those situations, now you know what formulas will apply, right? So if we're in the one-time payment, one-time lump sum scenario, the relevant formulas are, well, the simple interest formula. So that was the A equals P times 1 plus RT. You, of course, need to know the compound interest formula. That is A equals P times 1 plus R over N to the NT. Closely connected to this is the, sometimes you want to solve for the P and leave the A as the future value. So you can do that. The present value of a lump sum being that's going to be compounded in the future. Right. But again, you need to remember this is a one-time payment. It's like you're just, what is the money I need to put in now so that I can forget it, never put in any other money, and it grows to the FV, right? So one-time payment, you'd use this. Of course, there's the compounded continuously formula. And this is the A equals PE to the RT, right? So that's when theoretically your interest is being compounded an infinite number of times per year. That's the formula you use. Now, of course, these will all be stated, right? So anytime there's an interest situation, the problem, it should be stated to you in this class and in real life, right? Like if someone's charging you interest and you don't know how they're charging you interest, that shouldn't be a thing, that you shouldn't sign anything. They need to tell you, we're charging you interest compounded this way, or we're charging you simple interest. It's going to be in the fine print. It's going to be somewhere you need to know, right? So this is going to be given in the problem. So the problem is going to say blah, 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 compounded semi-annually, blah, 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 or blah, 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 compounded per month, blah, 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 right? Or blah, 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 compounded continuously, blah, 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 blah. It will tell you in the problem. Once you realize that it's a one-time lump sum payment thing, these are the formulas that are relevant to you. Do not think about any other formula, right? So that's the one-time lump sum kind of scenario. Now, of course, the multiple regular payment scenario are the formulas that we have been dealing with recently. That's in the last section of chapter 3, like 3.3, 3.4. So the formulas there that are important are the sinking fund formulas. Right, so call this Roman numeral I. We first encountered it. We first learned it as the future value of annuities formula, which we learned was FV is equal to PMT times 1 plus R over N to the NT minus 1 over R over N. This is, of course, equivalent to something that we call the sinking fund formula, which is the same formula. We just change the subject of the formula, right? So this is when we solve for payments. And the FV is on that side, the R over N is here, and the 1 plus R over N to the NT minus 1 is here. Okay. So that's the sinking fund formula. The next main formula we have is the present value of annuities formula. So this is the guy that goes PV equals PMT, the one that we were using today. 1 minus 1 plus R over N to the minus NT over R over N once again. This is, of course, equivalent to something called the amortization formula, which is the same formula. You just have a different thing that you want to solve for. This is, if you want to solve for payment, you can just rewrite this as present value R over N over 1 minus 1 plus R over N to the minus NT. Right? And that's the amortization formula. So those are the big boys, the heavy guns. These are the guys that are more realistic, right? Because it's more realistic for people to make repeated payments. No one just saves money in their bank account one time. You repeatedly put money in your bank account. You repeatedly make payments to pay down debt. You repeatedly make mortgage payments. You repeatedly, regularly save up for a college fund for your kid if you have a kid, or et cetera, right? So these are the guys that are really long-term planning, multiple payments. This is where you should be thinking. That being said, even here, there's still cause for confusion. You'll notice that these formulas themselves are similar. They have the R over N thing in the denominator. They both have the 1 plus R over N. One of them has the minus NT, but one of them has the NT. There's still enough similarity here to get confused. So how do we make sure we don't get confused? Well, we need to know what each of these is for. So so let's actually do that. When to use the above. So let's talk about 1. Use sinking fund if, okay, so here are the scenarios where you want to use formula 1, formula 1 in a problem, right? So you know it's a repeated payment problem. And so it's obviously going to be one of these two formulas or some variation of one of these two formulas. So which formula? So use sinking fund for the following reason. When saving up to a goal, you have some future, and that's kind of redundant, future value. Let's say some future obligation or FV, and you are making payments to achieve that FV. Growing with interest the whole time. So this is more like investing in the future kind of thing. Or maybe I should say investing for the future. Okay. So this is when you would use this formula. So you're reading a word problem, you realize, oh, there's multiple payments going on. And then you read something like, oh, a parent wants to save up for a college fund for their kids, or a couple wants to save up monies to make a down payment on a house, or whatever, right? So you realize, oh, people are saving up for some future obligation. They want to save in such a way that their money is growing with interest, so that by this time they have a certain amount. The sinking fund formula is your go-to formula. When do you use the other one? Use amortization if now it's like you're paying down a debt. Want to find the PV to have payments being made to you that will decrease the PV over time. While it's growing with interest. Another situation, of course, max purchase price. Right? Which is talking about how much debt can you afford at a certain interest rate if you know what payments you can make. Right? So you're in any of those scenarios, you want to use amortization, right? So amortization is all about paying down something, paying down debt. So there is a value of money that's growing with interest, but the goal is to whittle it down, right? So they give you a car loan, and your goal is to make payments to make it smaller, right? As opposed to a sinking fund where you're putting payments into an account to make it bigger because you want to achieve some debt. So you want to make something bigger, increase the value over time. It's a sinking fund. You want to decrease the value over time. It's an amortization, right? So that's how you would kind of know. These are the scenarios. So you can have one-time payments, in which these formulas come into play, or you can have multiple regular payments in which these formulas come into play. When do you use which formula? Well, in these situations, right? So that's just kind of a summary because we've covered a lot. We did a lot of examples. I just wanted to summarize so you know, kind of have an idea when you want to go in which direction. That would be very important. Now, for larger projects in your life, or perhaps in the project that we're going to have in this semester, we can mix and match these. Right, those guys up there. So I gave a very quick, somewhat morbid example before. So for example, here is you at 20 or whatever you are right now. And there's going to be a certain amount of years where there's going to be you at, say, 60, let's say retirement. And then there's going to be you at 90 where you die, right? You die at 90, right? So for some reason you're like, all right, I feel like after I retire, I'm going to live a maximum of 30 years for whatever reason, right? You have to just pick a number, right? Like, I'm not going to live to be 500. Like, how much do I want? How optimistic am I going to be here? Like, I expect to live in my 90s. Like everyone in my family, lives to their low 90s, whatever, right? This is kind of in the genetic cards for me. So you can kind of like make an entire life plan. You kind of expect this is what your life is going to be. So here is your working life, right? Here is where you're going to be investing for the future, right? So you're working, you save some of your paycheck, you're investing it, you're kind of growing because you want to have some amount of money at retirement to live off of when you're not working anymore. So this is retirement, right? So now you can kind of make a plan. You can say, well, I want to, in retirement, I want to be able to get $3,000 a month for the rest of my life, right? So you want to make sure that you can spend $3,000 a month out of whatever money you saved at retirement, and you can continually do that for 30 years. And of course, ignoring, when you're really making this plan, you have to take inflation and taxes and all that stuff into account, but let's just ignore all that for the moment and keep things simple. Then, yeah, what you want to do over here, that's an amortization problem. There's going to be some amount of money that's hopefully is invested in growing with interest that you want to pay down. You want to run out of money when you're 90. So this is how what PV is needed at retirement to get a certain fixed payment till you die, right? Amortization is a very obviously appropriate word for that. Amortization, like I said, the root word actually comes from mortality, which means death, right? So yeah, right? So you go to a financial planner. These are the calculations they're doing on your behalf, right? But now you can do your own calculations. You can check their calculations. You can look up on them. So yeah, this leg of your life is an amortization problem, right? Now, when you're young, that's not the case, right? So you know that there's some PV that you want to have here in retirement that's going to last you there. However, that's future you, right? From your 20-year-old perspective, right? That is going to be the future value you actually want to save up to, right? That's going to be equivalent to the present value that the old you has in his pocket, right? So at that leg of your journey, this is a sinking fund problem, right? I know how much money I need to have in retirement to be able to get $3,000 a month. So you have that figure in mind. So you know that in the future, when I retire, this is how much money I want. How should I set up my payments to achieve that in the future? That's a sinking fund problem, right? What payment do I need at what interest at some interest? Let's say you can assume what interest at some interest to achieve the FV for my retirement expenses. Right? So when you're young, you're in the sinking fund part of your life. It goes downhill from here, right? So those are the kind of calculations you're going to be doing. So you can mix and match them. You can have a problem that requires you to do both. You have to save up to something, and then eventually that thing is going to whittle down, right? So you use the sinking fund to save up to something, use the amortization to pay it down, right? So you might also be interested in eventually owning a home. So you're like, okay, in the next 2 years, I want to be able to have the down payment for a house. That's a sinking fund problem. How much money should I be investing now at what interest rate so that I have the down payment for a house in the next 2 years? That's a sinking fund. Then once you go to get a mortgage, how do I know what mortgage I can afford or what my monthly payments are going to be at a certain mortgage at a certain interest rate, that's now an amortization problem, right? So you use these when they're required. They're very special situations, right? So it's not just to pass a class, it's important. These are the kinds of things you need to consider for a very simple personal financial perspective. Business finances get a lot more complicated, but that's not the real goal of this class. This is just, the goal of this class is more general financial knowledge and things you want to know. So yeah, those are these formulas. And that's pretty much what I want to end on, but I will leave you guys with something to do for next class. Try these for next class. So we are going into chapter 5. And chapter 5, we're going to do things like linear inequalities, systems of linear inequalities. We're going to do linear programming. Now for that, the prerequisite is you need to be good at just regular old-fashioned systems of equations. So this is not in our syllabus, and I don't want to take time to teach you this. Because it's really something you should learn in pre-calc and algebra. So instead, what I was going to do is have you guys just sit down and watch me work through these problems, hoping that it will jog your memory about, oh yeah, I remember how to do that, right? However, I don't want to really rush through that in the next 6 minutes or whatever. So I will leave it for you guys to work out over this weekend. You can work it out in your groups or whatever, I don't care, but try to work this out. So in the first one, it's just a setup. You don't have to solve it, but ultimately you are going to end up, right? It says here, setup underline. So ultimately you're going to set up a system with, I think it's going to have 2 equations, if I remember correctly. 4 variables. Right? I list the variables down here, x1, x2, x3, x4, right? So you're going to read this problem, you're going to figure out what needs to be done, and you're going to set up a system of equations to answer the question. Then here's another one where not only do you have to set up a system of equations, but you have to also solve it. So it's going to be a 2x2 system. So you're going to set up something like, ax plus by equals c, dx plus ey equals f, and solve, right? By process of addition, elimination, or substitution, or whatever your fancy is. So yeah, so these guys are systems of equations like 2x plus 3y equals 7, x minus 2y equals 4, or what? I'm just randomly making something up. So this is like an example, right? I'm not going to teach you how to do this because it's I'm considering it as a prerequisite. You should have seen systems of equations before, but what we're going to do in chapter 5, you will need to know how to do this, or else, because in chapter 5, we're actually going to make the situation more complicated. We're not going to have equal signs. We're going to have less than or equal to or greater than, or we're going to make things a little more complicated. So you have to have this as a foundation, which is officially not in our syllabus. So up to you to make sure that you remember how to do this stuff. So I want you guys to try this for next week. I'll leave it in the notes. And that being said, I will let you go unless there are any questions. At this point, you can finish all your chapter 3 homework. We're done with chapter 3. And this is just a prep for chapter 5. So we're good. Are we okay? Are there any questions? Okay. Thank you for your attention. Hopefully most of you are paying attention. I don't know, your videos are off, but yeah, I will see you guys in the next one. Ciao.